Hi, and welcome to video 1.4, where we're going to talk about box plots and comparing distributions, because that's actually a big part of our statistics work, is comparing sort of different samples, different groups of people, things, to sort of see if there is a difference between those things. So the vocab we're covering here today is the 5-number summary and box plots. And you're going to find out how to find your 5-number summary, amongst some other things, and how to create a box plot on your calculator. So this is notes inspired by an old stats teacher at our school, Mr. Koning, and Mr. Koning's favorite basketball player was Michael Jordan. However, he understood that many of you are maybe Warriors fans instead. So what we have here, instead of looking at Michael Jordan stats, we're going to be looking at Warriors wins in a season, 20 seasons up to the 2014-2015 season when they won the NBA championship. So you can see that data there below is those 20 seasons. So what we're going to do is now move over to our calculator. We're going to enter this data, and then we are going to find our 5-number summary. So let's go over and do that. So the first thing we're going to want to do to get us started here is to make sure that we have the data put into one of our lists. So I have already entered all of the data into list 1. If you haven't done that, make sure that you do that before we proceed here. Otherwise, what I'm about to do won't work for you. So in order to find our 5-number summary, plus some other cool stuff, what we're going to do is hit stat once again, okay? But instead of going here to the edit, we're going to click over to calc. And we actually want this first one here. One var stats is going to be something we reference a lot throughout the year, standing for one variable stat. So if you want to come up with a lot of statistics about just one variable, in this case, the number of wins for Warriors in the last 20 seasons, well, then that's what we're going to use here. So when you hit enter, it's going to, if you have this version of the calculator, it's going to have this little menu for you. If you don't have this version of the calculator, it might have returned you to the home screen, and right now it's just saying one var stats, and then it's blinking behind it. What you're going to want to type in behind it is L1. For us that have this newer sort of upgraded interface, we have here just what list do you want, and you can change it if you put it into a different list, but all my stuff is in list 1, so that's it. Frequency list, we're not messing with right now. Eventually we'll see what that is for, but it's not useful for us right now. And then you're just going to hit calculate. And you can see that it shows you a bunch of different information, some of it needed for us to continue the worksheet, some of it just kind of interesting things. So for example, we have here X bar. We know that is the mean. So the mean of our sort of wins here is 35.25. There's a bunch of other stuff that we don't use too much, but you can kind of make sense of it. The sum of all your X's, the sum of the square of your X's. And then we have here S. That is the standard deviation, 15.946-ish right there. In case it was a population instead of just a sample, this would be it. It's different. If you really want to know why there's a different calculation for population versus standard deviation, I believe there's a PDF in the master documents that kind of goes into that. You can also pop by for Flex to ask about it. How many things are in there? 20. What we really want, though, is down here. Down here is our 5-number summary. We've got our minimum, we've got our first quartile, the median, third quartile, and the maximum. So anytime you want a 5-number summary, this is the place to go. Anytime you want to figure out what the mean and standard deviation of your sample is, this is the place to go. So that's our 5-number summary right there. So now we're going to scale the axes down here in number 5 in order to make sure that our data will fit here. So to kind of do that, you can sort of think about like, okay, I need to get from 17 to 83. So 83 minus 17, I believe it's 66. So I need to get 66 total along this here. I think there's 12 chunks down below. So like 66 divided by 12, I think is like 5.5 right there. So round up. We're going to go like, spaces of 6. You can start at 17 and go spaces of 6. Might be a little bit weird. I'm going to start at 15, okay? and then go by sixes, so 21, 27. Those are like, actual multiples of 3. So kind of makes sense. We're going to go with it. If you wanted to scale it slightly differently, that's totally fine. You just need to make sure that all of your data will lie on here. The other thing we need to make sure we do is label that. Some people get scaling and labeling confused. They're different. I just scaled my axis right now. You want to make sure you also label it, which is going to be Warriors wins. That is ugly. Sorry for the bad penmanship. So there you go. I've got it scaled and I've got it labeled. That's something that's always going to be important and checked as part of your grade when it comes to making these sorts of things. All right, what are we doing next? It says we want to identify the middle 50% of the data by putting some lines down to represent the quartiles and the median. And that's our sort of box. So I'm going to do that. So I'm going to go ahead and draw in my first quartile at 22. Okay, 22 is just a skosh over here to the right of 21-ish. There you go. My third quartile is 42.5. Okay, so that's going to be over here, about halfway between the 39 and 45. And then the median is a 34 right here, just a little bit after 33. And then I'm going to go ahead and connect the quartiles together to create the box. So that is the box in the titular box plot. So there's my IQR represented with that middle bar representing the median. Beautiful. All right, our next step. We got to figure out outliers, okay? So outliers in these particular cases, I told you there's a rule for them, and here's what the rule is. If you have any data points that lie 1.5 IQRs away from your quartiles, then it's considered an outlier, okay? So the first step in trying to find our outliers is to first find our IQR. So IQR, that's going to be 42.5 minus 22, which gets us 20.5. And what I want to do now is figure out if I multiply that by 1.5, if I move from the left to the left on my first quartile far enough, do I have any data points that fall below that? And then same thing moving to the right. So we're going to go ahead and find these sort of fences, if you will. I'm going to mark them in with little dashed lines. You can do that if you'd like. You also don't have to do it. So here we go. We're going to go ahead and go with first quartile minus 1.5 times the IQR. So our first quartile is 22 minus 1.5 times 20.5. If you toss that into your calculator, you're going to find that you get a negative 8.75. So I don't even have negative 8.75 on my scaling here. And in fact, contextually, negative wins does not make any sense for this. So I am pretty certain that I have no lower outliers, and that is confirmed. There are no values up in my table here that are below negative 8.75. So no outliers to the left at all. But I got to check the other way. I got to also go third quartile plus 1.5 times the IQR. So to the right. So we're going 42.5 plus 1.5 times 20.5. Toss that into the calculator and I get 73.25. So that does show up here on my bar, my axis here, 73.25. That's like here-ish. I'm going to go ahead and mark. And so now I want to know, do I have any particular data points that fall above that? And yes, I do. I have a singular value that is above 73.25. Right here, the last data point, 83, when they had that miraculous run of like just winning almost all the games. That is going to be an outlier. So what do I do to draw an outlier? Well, what I do is I put it separate. It's going to be separated from all the things. That's what sort of notes that it's an outlier. It's separated from it all. So I'm going to go ahead out here at 83, and I'm going to put a little asterisk right there at 83. I'll even write next to it, oh, I should put that in blue because that's what color I'm doing my box plot in, so 83, and I'll write 83 right here. Cool. So now let's move on to drawing our whiskers, okay? So the whiskers extend to the maximum and minimum with a caveat. If you have outliers, then you extend to the furthest data points to the right or left that is within sort of your fences. So in my case here, as I look through my data, 83 is the outlier. The second largest number that falls below the fence is 53. So that means my right whisker is only going to extend to 54. I even circled it. I said 53. So it's going to extend only out to 54, not to the fence, not all the way to the maximum. So here, I'm going to go ahead and draw in 54. That's like right here-ish. And the lowest value, my minimum was 17. So I'm going to go ahead and draw a little thing like that. And then I draw little whiskers going out to those. I don't draw those lines as big for the max and min. You can. It's totally fine. It's not wrong to actually draw them as just as large. I don't know why. I just draw them a little bit smaller. So there you go. That is our very first box plot that we have created for each other. So as you can see there in number 5, it sort of talks about how there's sometimes these things called far outliers that are 3 IQRs away from the quartiles. We just talk about them as outliers. You don't have to worry about finding far outliers. But if you did maybe do some of your own research, you might see. So the great thing about your calculator, though, is it can make box plots for you, so you don't have to necessarily do it all by hand. Let's go see how to do that. So let's create that box plot that we just did by hand using the calculator. So what we're going to do is we're going to hit second and then stat plot. And we're going to just go to the first one. Doesn't really matter which plot you want to use. We're going to go to the first one. The first thing I'm going to do is make sure that this plot is turned on. So I'm going to turn it on just in case it's off. And we're going to go ahead and arrow over to box plot. You'll notice that there's 2 different box plot diagrams there. What's the difference? The difference is this one will show outliers with little dots. This one will not. This one will just ignore any possible outliers at all. We always want to do this one because we do care about outliers in this course. So we're going to go ahead and press that. For your X list, I have still my data in list 1. Again, if you have it in a different list, make sure that you adjust that. Frequency 1 is fine. You can change it so that way the outliers are different things. So mine's just going to show a square for an outlier. You can change it to a plus or a dot. I really don't suggest using the last one. It is so tiny, you might miss it. So just make sure it's something that's really visible. And then just as I usually do, I'm going to hit zoom, and then I'm going to hit 9. And there you have it. So you can see that that looks very similar to what we have on our page there. But if you really wanted to make sure that things went well, you can hit trace. And trace will allow you, just like with a histogram, allow you to kind of bounce around from, in that case, bin to bin. Trace here by clicking left and right allows you to bounce around to your quartiles. It'll even bounce out to the outlier out there. So if you are ever dealing with this and you don't want to make a box plot by hand, you can do it in the calculator really quickly, and then you can just hit trace to see like, okay, here to here to here to draw it all out. So what does this all mean? What do we use this box plot for? Why are we breaking it up like this? What's the whole point? Well, the great thing about being able to sort of look at the box plot and what you can read immediately is like you get to see where the 25% chunks are. So you can figure out where the lower quartile is, the upper quartile, the middles, and be able to come up with a pretty good analysis of things pretty quickly, and because of how this is organized for us. So to sort of show that, why don't we look at some questions here that will allow us to sort of see the usefulness of a box plot. So I'll do some of them, and then why don't you actually finish them out as we sort of go along here. So I'll help you out. First one, so these 20 seasons here, the Warriors' upper 25% seasons were between blank and blank wins. Do you think you know what it is? Take a moment, and hopefully you said 42.5 and 83 wins, because that is the third quartile to the maximum. That's the upper 25%. Remember, third quartile means the 75th percentile. So that's the upper 25 is your 75th percentile there. So I think you can answer B now without any trouble, and C. Why don't you do that? Moving on to D. So the Warriors' 83-win championship season was surprising, as it was an, can you guess what's going to go on that blank? It was an outlier. As we calculated our fences there, we saw that it is on the right side of that upper fence. How about this next one? The Warriors won no more than blank games 75% of the time. The Warriors never won more than blank games 75% of the time. What's that one going to be? Hopefully you said 42.5 as well for this one, just like in part A, because yeah, that is the 75th percentile right there. So 75% of the time they won less games than 42.5. And if you're wondering, well, hold on, how could they win 42.5 games? Well, it's because we have 20 data points. And so our upper, if we split that in half, 10 and 10, that means we're dealing with just 10. It's an even number, so the third quartile as well as the first quartile fall between two data points. Just so happens that the first quartile, when you averaged it out, came a whole number, and for the third quartile, it ended up being just a half, which is okay. F, the Warriors would have had to have won fewer than blank games to be an outlier. What would that have to be? That was negative 8.75. If you remember back in our work for finding the fences, of course, that's an impossibility. So that's a reason why we have no lower outliers, is that it would have to be negative wins, which doesn't make any sense. Looking on to G, did the Warriors have more seasons below 22 wins or above 42.5 wins? Think about that. Look at the graph. What would it be? It's a trick question. Actually, it was an equal number of seasons because they are in the 20. They are the two quartiles there. So 22, that 20 below that is 25% of your data, and then at 42.5 above that is 25% of your data. So it is the same amount of seasons. It's 25% of the seasons we collected, which is just 5 seasons in total because we only grabbed 20 seasons. But that's sort of the point there. So this demonstrates one of those most common mistakes with box plots. So even though that the whisker on the upper side is a little bit longer than the one on the lower side, that doesn't mean that there's more data in there, okay? It just means that the data has more spread or variability. So shorter whiskers, skinnier boxes means that there's not a lot of variability or a lot of spread. The longer the whiskers, the longer the boxes, more variability, more spread to it all. So it does not mean that there's more data in there, just more spread. So we're moving on to the backside now. So now that you know the basics of box plots, one way we can really use them is to help us compare distributions, especially when your data sets get really enormous. Like obviously if you had like 800 different data points, I'm not expecting you to create box plots by hand. Instead, they'll probably be provided for you. And then there's going to be like a series of questions or claims that you have to defend or maybe prove to be false. So what we're looking at here are something called parallel box plots, called because they're sort of, lined up parallel. This time around, they're vertical. So when we are doing the Warrior seasons on the front side, did a horizontal box plot, but you can do them vertical like this. You'll note that the axes here increases as it moves upwards there. So it's still sort of making sense on all of this. So be okay dealing with that and sort of thinking about that. So In this example, the box plots display the relationship between the number of cylinders a car's engine has and the car's fuel economy in miles per gallon selected from a sample of cars. So what I'd like you to do is see if you can answer these 4 questions independently. Make sure you pause the video and try them out. And then when you are ready to sort of answer them, unpause, and then I will show you the answers. So make sure you do that to really think about independently working through these things. All right, hopefully you did actually pause it and give it a shot to at least think about these things before writing down answers. So here it is. The first one, are there any 8-cylinder cars as fuel efficient as is any of the 4-cylinder cars? And explain. Well, no. So since the maximum 8-cylinder efficiency is at about 20 miles per gallon, and that falls below the minimum for 4-cylinder efficiency at about 22 miles per gallon, that means there's no overlap at all. So there's no cars that are 8-cylinder and 4-cylinder with the same fuel efficiency. Part B, true or false? All of the 4-cylinder cars are more efficient than the 8-cylinder cars. That is not true. That's going to be false here because we see some overlap here. So, I always forget I have this. So we see some overlap here. So if we're looking at the lower 25% here for my 4-cylinder cars, that almost lines up perfectly with the upper 25% for my 6-cylinder cars. So there's a lot of overlap here, which means that that's not true. Not all. A lot of 4-cylinder cars are more efficient than 6 cylinders, but not all because of that overlap. Part C says the median line for the 8-cylinder cars is fairly low in the IQR box here. What's that mean? It means there's not a lot of variability. Frankly, that IQR box is pretty squished. Those whiskers are pretty squished. So there's not a lot of variability for 8-cylinder cars in terms of fuel efficiency. Certainly not as much as we see over here with our 4-cylinders, where we have much longer whiskers, much wider boxes there, or taller, I guess, in this case, since we're going vertical. The last one, Part D, what's going on with 5 cylinders? Did it misprint or what? No, it's just a single line. What it means is there's no variability. So, 8 cylinders has very low variability, 5 cylinders has no variability at all. What that means is either there's literally one car in this sample, which I don't even know why they bothered to then show this sort of thing, or perhaps they actually did collect a few cars and they are literally all the same fuel efficiency. They're all at about, looks like 21-ish, 20.5-ish miles per gallon. So that's what's going on with that, not a misprint. Why don't we move on to the last bit that I'm going to have you do on your own, because I know you can do it. So here we have a couple of groups that are being studied here for cholesterol. So a university wants to conduct a study of new medicine that is designed to help with high cholesterol. Below are the ages for 2 possible groups of patients that could be used in the study. So your first step here is to create parallel box plots. Okay, don't forget to label and scale. Check for your outliers. And the next thing I want you to do is answer that question down below. Which study group do you think would be more appropriate for the study of the medicine, and why do you think that? So go ahead and do that. Finish this up. Come in ready to talk about this, and have a great day.